welcome back to On the Spot STEM, and today we'll be doing number 24 from the 2020 AMC 10A. The problem reads, let n be the smallest integer greater than 1000 such that the greatest common denominator of 63 and n plus 120 is equal to 21 and such that the greatest common denominator of 63 plus n and 120 is 60. Find the sum of the digits of n. So first off, we realize that n plus 120 is congruent to 0 mod 21. Now we can simplify this to n is congruent to 6 mod 21 using our basic modular arithmetic rules. Dividing 120 by 21 to get -1 and then adding 7 to both sides to get n is congruent to 6. Now the second statement shows us that n plus 63 is congruent to 60 mod, 0 mod 60. And we can again simplify this to 57 mod 60. Now we want to find an integer that satisfies both of these conditions, and the simplest way to do that is just list possible n's that satisfy the second condition and see which one of those satisfy the first. So when we list out the four values that work, we have n equals 57, 117, 177, or 237. And from just checking, we find that 237 is the only value that works. However, we're not done. This is clearly not greater than 1000, which is what we want. But when we look at these two statements again, we find that from the first statement, if we ever add 21 to n, or a multiple of 21, the statement will still hold. As in, n plus 120 will still be a multiple of 21. And in the second equation, we find that if we add a multiple of 60, 63 plus n will still be a multiple of 60. So what we can do is add multiples of 21 and 60, and the least common multiple of 21 and 60 is 420. So let's just list some values of 237 mod 420. First we'll get, of course, 237. Second we'll get 657. Third we will get 1077. And this is the first one that we can check, right? Now let's check this value 1077. When we look at our first statement, the greatest common denominator of 63 and 120 plus n equals 21, we quickly see that 1077 does not work. And the reason is as follows. When we add 1077 to 120, we get 1197. The problem with this value, 1197, is that even though it's a multiple of 21, it's also a multiple of 9. And those two combined make it a multiple of 63. And since we have 63 here, this would make this statement equal to 63, not 21, which is, we don't want that. So 1077 doesn't work. We'll take the next value, 1497, and we also face problems when we look at this. So we find our second statement, GCD of 63 plus n and 120 equals 60. And when we add 1497 plus 63, we get 1560. Now this is a multiple of 60 like we want, but it is also a multiple of 120. And like before, it would make the equation equal to 120, not 60, and we don't want that. So we can go back and add to our list, as this doesn't work, and the next value we get is 1900 17. And this does in fact work, and we can go through it now. So 1917 by our first expression over here, GCD of 63 plus 120n. And when we solve for that, we get GCD of 63, and 120 plus 1917 is 2037. And this is in fact equal to 21. We know this is a multiple of 21 from how we found these numbers, but it's not a multiple of 9, which ensures that it's 21 and not 63. And our second thing is GCD of, and when we add 1917 to 63, we get 1980 and 120. And this is also in fact equal to 60. And the reason is this right here is not a multiple of, this right here, 1980 is not a multiple of 120, which ensures that this is 60 and not 120. So we get that the value 1917 does in fact work. And what this gives us as a sum of the digits is 1 plus 9 plus 1 plus 7 equals, this is equal to 18. And this right here is answer choice C on the AMC 10A. Thank you guys for watching. If you enjoyed this video and want to watch more, we have more AMC 10 and AMC 12 videos coming up, and we hope you enjoy them.